welcome to the session. Today we will discuss multiple reflections in a thick mirror. So, before we start, we have already seen in previous session that when there is a reflecting surface and there is an incident ray obliquely and incident ray that is oblique to the normal, a part of this ray is reflected whereas the remaining part gets refracted. So this reflected ray we have studied in 9th class and we are studying refraction now. Okay, so light is nothing but a form of energy. So if 100% is the light that is falling, so around 4% of this light energy is reflected and remaining 96% gets refracted. So this we should bear in mind, that reflection is a mere approximately 4% of light energy, whereas the remaining will go for refraction. Okay. Now consider the MNPL on the screen. This is a very thick mirror. You see the shaded portion? That is the polished end. Like this end is polished with a silver surface and this end is a reflecting surface. Okay, now consider an illuminated object placed at point A, an illuminated object placed at point A, and an observer is looking obliquely at this illuminated object. So, firstly, the observer finds that this illuminated object forms a series of images. They are continuously fading, but for the second image, which is the brightest. So what does the observer observe? For an illuminated object A, while he is observing obliquely from this position, he can see a series of virtual images which are continuously fading. Among those images, second image is the brightest. Now why is this happening? Let us see. Consider a light ray which is falling along the line that is perpendicular to this reflecting surface. Consider a light ray. And another light ray along AB which is oblique to the surface. Okay. So this AB is incident ray. A portion of it, that is around 4% of it, is reflected from the surface ML. From this surface, a portion around 4% will be reflected along the line BP. The remaining 96% would be refracted along the line BB dash. Okay. So again at B dash, this light is reflected totally, and this internally reflected light along B dash C after hitting the first reflecting surface will get refracted along the line CQ. So this is approximately 96%. So for an observer, he can see a series of images. A1 is the first image, A2 is the second image, A3 is the third image, A4 is the fourth image, and A5. These are all, the intensity of the image is fading continuously. So if you see, the first image A1 has only 4% of light energy. So this is very feeble. But if you see the second image, 96%. So this image would be the brightest. And this phenomenon continues further. From this surface, again, a part of energy is reflected, which would be 4% of 96. And this energy will again be totally reflected internally. So this reflection and refraction keeps continuously happening, and an observer will find series of continuously fainting images, A1, A2, A3, A4, A5, whereas A2 is the brightest. Understood? Let's move to the next topic. Now, let us see the terminology of a glass prism whose cross section is triangular. Have you seen that prism anytime? So its cross section would be triangular. If you see on the screen, so this is the prism. So let us see what terminology is used. So we should be well aware of the like nomenclature and terminology of the prism. It has got two cross sectional. See, cross section is triangle, so this is one, the front side, and the back side, this is two. So this cross section is a triangle all the time, and there are three rectangular surfaces: surface 1, surface 2, and surface 3. So the bottom surface is always called base because the light ray will fall incident on this surface, it gets refracted along here, and it gets again like this. So approximately I am drawing. So this surface is called base. This is refracting 2, and this is refracting surface 1, and this is refracting surface 2. This top edge is called a refracting edge, and this angle ABC is called angle of the prism. And a prism is represented in a ray diagram as a triangle like this. Clear? Now, in MCQs there could be questions on this which are basic, but if you are not aware, you might get them wrong. So there are two triangular surfaces with identical triangles. So these triangles could be equilateral, isosceles, or other triangles. But whatever triangle is the first, it will be exactly same. So on the other side. So they are identical triangles. Second, there are three rectangular surfaces, 1, 2, and 3, inclined to each other at an angle. Okay, which is always acute angle. And if you count the total plane surfaces, there are altogether 5 plane surfaces. Okay, 1 and 2 triangular surfaces and 3 rectangular surfaces. So there are altogether 5 plane surfaces, and there are altogether 9 edges. So 3 edges on one triangle, another 3 edges on another triangle, 6, and 3 edges on the rectangular reflecting surfaces. So 3 plus 3, 6, 6 plus 3, 9. So there are totally 9 edges. So we should be conscious about these numbers. Let's move further. Now, let us see how a light ray undergoes refraction through such a prism. So on the screen you can see there is a prism which is denoted by ABC. Okay. So a light ray OP which is incident at an angle of I1 falls on one surface AB of the prism. this is the normal at the point of incidence. Okay, so this incident ray, because it is moving from rarer to denser, it bends towards the normal and moves along PQ. So PQ is the refracted ray. Then when it hits the other surface AC, it again undergoes refraction. Because it is moving from denser to rarer medium, the refracted ray tries to move away from the normal. So it is refracted along QR. So OP is the incident ray, I1 is the incident angle, PQ is refracted ray, R1 is the angle of, sorry, yeah, R1 is the angle of refraction. Then R2 will be the second angle of incidence internally. Then I2 would be the angle of emergence. So QR is called an emergent ray, and the angle I2, it is called angle of emergence. So I1 is angle of incidence, R1 is angle of refraction, R2 is angle of incidence, I2 is angle of emergence. Okay. Now we have seen here the angle of prism at A, that is angle BAC, is one angle. And if you see the construct, suppose I am extending the incident ray direction along PL and I am extending emergent ray along QM. So this extended emergent ray direction, if it meets extended incident ray direction, let us call that point of intersection M. So this original direction of incident ray will form an angle of called by delta with a final emergent ray direction. This angle of this delta is called angle of deviation. So finally the incident ray has been deviated to the extent of angle of deviation. So the light ray will tend to move towards the base of the prism. Okay, so understood? Now let angle MPQ be denoted by delta 1 and angle MQP be denoted by delta 2. Take your time to understand the various angles and the nomenclature of this ray diagram. Now here, these relationships we should memorize. We will see how they are derived in a short while, but we should memorize them. Firstly, the angle of the prism A will be equal to sum of angle of refraction and sum of angle of refraction and angle of incidence, internal angle of refraction and internal angle of incidence. So R1 and R2. So A will be sum of R1 and R2. That is first relation you should memorize. Second, this delta angle of deviation, it is given as I1 plus I2. So sum of angle of incidence plus angle of emergence. So sum of them minus R1 plus R2. So deviation is, the angle of deviation is given as I1 plus I2, that is I1 plus I2 minus R1 plus R2. So this is another relation. So if you add these two, A plus delta is equal to, so R1 plus R2 gets cancelled. So A plus delta is equal to I1 plus I2. So these relationships we should memorize. We will see how it got derived. Okay, let's move further. So I have blown up for clarity. See, can you see the triangle PQN? So this is the triangle. Can you see the quadrilateral APNQ? So this is the quadrilateral. And can you see the another triangle PMQ? PMQ. This is the, and can you see the straight line PML and the and this line MQ? So these. So I have projected them separately for the sake of clarity. So firstly, look at the angle of incidence I1. I1, if you see, these are vertically opposite triangles. So I1 is equal to delta 1 plus delta 2. I1 is equal to delta 1 plus R1. Okay. From this we can get delta 1 as I1 minus R1. Call this as equation 1. Likewise, if you see here, I2 is vertically opposite to this angle MQN. So I2 is equal to delta 2 plus R2. From this, delta 2 is we obtain as I2 minus R2. So let us call this as equation 2. So these two relationships we got from angle of incidence and angle of emergence, and their corresponding internal angles R1 and delta 1, R2 and delta 2. Okay, clear till here? Now, first you should remember in derivation, first we will look at this triangle, then second is quadrilateral, third is this triangle, and finally the straight line. That is the order. So consider PQN, this triangle PQN. In this PQN, R1, R2. So sum of three angles in a triangle is 180. That means R1 plus R2 plus angle P and Q would be 180. From this we are getting angle P and Q as 180 minus, I am taking this R1 plus R2 the other side of the equation. So we get this, let us call this as equation 3. Okay. Now consider the quadrilateral PAQN. PAQN. So I have projected it here. So sum of all the four angles in a quadrilateral is 360. That means angle APN, angle APN plus angle AQN plus angle APQ plus angle PQN, they all should equal 360. It is the property of any quadrilateral. Sum of all the angles will be 360. So if you see, angle APN is perpendicular. Angle APN, because this is the normal. So this is the normal to this surface. So this is perpendicular. Likewise, this is normal to this surface. So these two angles are perpendicular. So APN is 90, AQN is 90. This angle PNQ, and this is the angle A. So PAC, like PAQ, angle PAQ, I am just denoting it by angle A. This is the angle of prism. Okay. So now, if you simplify this, we can get A as 180 degrees minus PNQ. Okay. Now, from equation 3, we have a value of P and Q. So if you substitute this P and Q in this, A is equal to 180 degrees minus of 180 minus R1 and R2. From this we get as A as R1 plus R2. So this is the first relationship we got. So angle of prism is equal to R1 plus R2. This we should memorize. Next, consider the triangle PMQ. PMQ, that is the top triangle, and I have projected it here. The same thing, sum of three angles in a triangle is 180. So here delta 1 plus delta 2 plus angle PMQ should be 180. So angle PMQ, we get it as 180 degrees minus of delta 1 plus delta 2. So let us call this as equation 5 and this as equation 4. Okay, now consider the straight line PML, this PML, and this projected emergent ray MQ. Okay, so any straight line, the angle LMQ plus angle PMQ would be 180 degrees. Any straight line will bear 180 degrees. So angle PMQ, that is PMQ plus angle, this is delta. So this is delta, angle of deviation. This will be 180. From this we get angle PMQ is equal to 180 degrees minus delta. Okay. But we already got PMQ as this expression. If you are substituting equation like PMQ value from equation 5, then we get 180 degrees minus delta 1 plus delta 2 is equal to 180 degrees minus delta, that is angle of deviation. So from this we get angle of deviation is nothing but delta 1 plus delta 2. So that also we can remember. The total deviation is nothing but internal deviation, delta 1 plus delta 2. So this delta is equal to delta 1 plus delta 2. See, this is also a geometric property we have learned. Directly we can say that delta is delta 1 plus delta 2. So this is another relation which you need to memorize. Now from equation 1, because we have delta 1 and delta 2, see delta 1 and delta 2 we got from these two equations. So if you substitute those values in this equation, delta 1 is I1 minus R1, delta 2 is I2 minus R1 from this two equations. If you substitute, then delta will become I1 plus I2 minus R1 plus R2 is nothing but R1 plus R2 is nothing but A. So I can write R1 plus R2 as A. So this would be like if I rearrange angle of A, angle A plus delta is equal to I1 plus I2. So angle A, that is angle of prism, plus delta is angle of deviation is equal to I1 angle of incidence plus I2 angle of emergence. So this nomenclature and relationships, we should dwell with this ray diagram uh, till the time you are comfortable with it, understand the terminology used, and also memorize the relationships. So this is the process that a light ray undergoes as refraction through a prism. Understood? Let's move further. So what are the factors that affect this final deviation? See, incident ray has been finally deviated by an angle of deviation delta. So what are the factors that affect this angle of deviation? So if we increase the angle of incidence, what will happen to the angle of deviation? So if we take another prism, what will happen? If we take the angle of prism which has more angle or less angle of prism, what will happen? Then if we take various different colors of light, what will happen? We'll see. So there are four factors that affect the angle of deviation. The first one is the angle of prism. So this angle of prism. The greater the angle of prism, the greater the angle of prism, the greater would be the angle of deviation. First relation. Second, the angle of incidence. Suppose I go on increasing this angle of incidence. So how do we increase angle of incidence? So when we are doing this experiment, we keep a light source here. We keep a light source here. So this prism will be slowly turned clockwise to increase this angle. That is how we increase the angle of incidence. So when the angle of incidence is increasing, what will happen to the angle of deviation? So let us see. There is a specific observation. So as we increase the angle of incidence, first the angle of deviation reduces to a minimum value of deviation. After you cross that minimum value, the angle of deviation increases. If you see this angle of incidence minus deviation, angle of incidence hyphen deviation curve, it is called I delta curve. So on the y-axis we have taken angle of deviation, and on x-axis we have taken angle of incidence. So as the angle of incidence is increasing, as the angle of incidence is increasing, initially the deviation decreases until it reaches a minimum value. This is delta minimum. And after that, when the angle of incidence increases, the angle of deviation will increase. So this specific behavior has to be noted. So when the angle of incidence is increasing, initially angle of deviation will reduce until it reaches a minimum deviation angle, delta minimum. After that, any increase in angle of incidence will increase the angle of deviation. That is also given by this curve, I delta curve. So the position of the prism, I told you how to increase the angle of incidence. The position of the prism when the angle of incidence or the position of the prism where the angle of deviation is minimum, that is called minimum position of the prism. At that position, it is observed that angle of incidence will be equal to angle of emergence, and then R1 and R2 are also same. Okay, so note these relationships. So A will be R1 plus R2. So in this case it is R. So A will become 2R. So the angle of prism is given by 2R, and angle of deviation is I1 plus I2 minus A. So I1 and I2 are equal. So 2I minus A. So these are the relationships under that specific condition at that minimum deviation position of the prism. So when the prism is at minimum deviation position, if the prism is equilateral, that is if all the three sides are equal, or if the prism is isosceles. Isosceles means these two sides are same. If the cross section of the prism is any of them, equilateral triangle or isosceles triangle, then this refracted ray PQ will be parallel to the base of the prism. Understood? Let's move further. Now, material of the prism. So when we say material of the prism, we are talking about its refractive index. So you remember our stack of optical media. vacuum, air, so on, so the densest at the bottom. So as we go down, wavelength and velocity reduces, but refractive index increases. So remember this stack of optical media always to keep like the trend of any property, whether it is increasing or decreasing, is very confusing. So many are there. So if you want to fix them in mind, always draw this stack of optical media and see what is happening when you move from top to bottom. So that is the reason why I took Vibgyor also in the reverse order here in the fourth point. We'll discuss in a while. So for the material of the prism, see when as we go down in the optical media stack from top to bottom, what is happening to the refractive index? Refractive index is increasing. So when refractive index is increasing, the angle of deviation is also increasing. Just keep this in mind. So actually this happens for a glass. So glass is somewhere in between. So when the refractive index of the glass is increasing, then the angle of deviation is increasing. So here, with respect to this prism, so if refractive index of this prism is increasing, then angle of deviation is also increasing. That way you should keep it in your mind forever. Now fourth, the last factor on which the angle of deviation depends is the color of light. So I have drawn this visual spectrum like Vibgyor in reverse order because it follows the same pattern where when you move from top to bottom, wavelength and velocity decrease, and so therefore refractive index increases. As we go from red to violet, wavelength and velocity decreases, whereas refractive index of the medium increases. Let us so whenever the wavelength and velocity decrease, refractive index will increase. The same analogy what we do from optical media stack. So for red, wavelength and velocity are maximum, and for violet, wavelength and velocity are minimum. So the angle of deviation, it increases as we move from top to bottom. That means whenever the wavelength decreases, angle of deviation increases. So you have to keep these relationships and and fix the trend that is happening here in your mind by dwelling with the how the trend is happening using this optical media stack or this Vibgyor stack. Okay, so let us end our session there.